Welcome to the ninth problem from Blind75, which is merge k sorted list. You have already seen in the past problem, which is merge to sorted list, and I hope it will help you to find a solution for this. So let's take a look at the problem. This is a hard problem. And you are given an array of k linked lists. So in the previous problem we were given two linked lists. Here it is k linked list. Each linked list is sorted in ascending order. So it's a similar way in the previous problem. It is the linked list is in a sorted order. Merge all linked lists into one sorted linked list and return it. So so let's take a look at the example. 1 4 5 1 3 5 2 6. So the output is going to be 1 1, then 2, then 3 4 4 5 and 6. Okay, so we merge them. So if it is empty, return empty. And let's look at the, so in the example the linked list can also be an empty linked list. So k is the length of the list, linked list here, not the one, the entire list. And yeah, the k can be up to 10 to the power 4, which is 10,000. Then each linked list can be of length 0 up to the length 500. That means we need to handle the empty linked list edge cases, and the value can be somewhere from minus 10 to the power 4 to minus plus 10 to the power 4. So the value, each value in the linked list can be minus 10,000 to 10,000. It can be minus 10,000 minus 9999 or plus 9999 and 10,000. So 9,999 is what I meant. So it can be anywhere in between, and it is sorted already. Each of the list is sorted. The sum, so we are given this list, right? So this sum of the length, that means the length cannot be more than 10 to the power 4. Okay. What is the brute force solution here? So let's see the obvious solution is to create a list of all the values in this linked list, each of the linked list, then sort it and then create a merged linked list, right? So we can do that. So that is a brute force solution. Let's see how we can implement it. Okay, so let's see. So we need a list which stores the values of each of the linked list, and we need a dummy node, right? So dummy node is equal to list node of 0 or minus 1, whatever you feel like. And so I'm kind of keeping this as dummy node so that we can reference it later. So instead of dummy node, let me call it as node, and head will have the reference of the merged linked list head. Okay, so let's find all the values and add it to the nodes. Let's do it. For L in list, we are taking each of the list, while L, so we are iterating through each of the list, nodes dot append of L dot value, then L will become L dot next. So at the end what we will have a we will have a list which contains all the values here. And what we will do is we will iterate, like sort this list and create the linked list while iterating itself. How do we do it? So for x in sorted of nodes, so we are sorting the nodes here. Node dot next is equal to list node of x, then node will become node dot next. So we keep iterating and building it, right? And at the end what we will return, we had the head reference saved here, which is head dot next. This is actually a dummy node, so head dot next. Let's try running this. Yeah, this works, but what will happen if we submit? This is probably going to time out because the length can be big. Um, okay, so is there any other way to solve it? Before that, let's take a look at the complexity. What's the time complexity here? So the time complexity is so we iterate where n is the number of nodes in the all list summed up. So we need order of n to iterate through this, right? We also need order of n log n to sort it. So ideally it is order of n plus order of n log n, right? So we can say it is order of n log n. What is the space complexity? Since we use an additional memory to store the values, the space complexity is going to be order of n, where n is the total number of elements or total number of nodes in all the list summed up. Okay, so yeah, there you go. And let's take a look at another. Can we optimize it? So the comparing elements in two linked lists was easy. But can we do it using a different data structure? Yes, we can use either a min heap or a priority queue here. So what we will do is we will add the first element along with it, yeah, the linked list references to the priority queue. And yeah, I'll try to write here, for example, say this is the priority queue, and the lists are, say, 1 4. Okay, let's we can take a look at this example. So here 1 4 5, this is one linked list. 1 3 4, this is another linked list. The other one is 2 6. So what we will do is here yeah, so we will add the first all the linked list links here. So there are three right here. So the say L1, L2 and L3 in this case, and we pop it. So from here it compares the list and we get the list with the smallest value. So suppose in this case we got L1. So what we will do is we create a dummy node, say dummy node of -1. We'll do -1 dot next as the popped value, which is 1 in this case, this one. So what then what we will do is we will add this instead of L1 we will add L1 dot next, which will be pointing to the 4. Then we will pop again, then we get again 1. So this will be pointing to 4, this will be pointing to so this is again 1, right? So 1, so L2 will be pointing to 3 here, so this is 3. L3 is pointing to 2. So out of this, which one has the lowest value, which is 2? So 2, and then this will point, so we will keep adding L3 dot next. So this is 6. Then 4 3 6, which one is smaller? 3. So we will add 3 to the next in the next iteration. Then the 3 will become 4, like 3, it will be pointing, the L2 is pointing to 4. We'll do L2 equal to L2 dot next and add it to the priority queue and so on. So similarly we'll keep adding it to the priority queue. So we can either use priority queue or a min heap. So in Python the heap is by default min, so it is easy to implement. So here I'll use priority queue. There's a small difference here in Python 3 in the comparison. So I'm going to write the comparison, like override the comparison wrapper here, which is wrapper, and we need an init method for the priority queue, which is cell.node. Cell.node is equal to node. I'm going to add the reference only, the head or the node reference. Start in the starting it will be head, then when we move forward we'll iterate through the next element and we add it to the priority queue. So how do we compare? So we so I am overriding the comparison method of the priority queue and we'll use this wrapper when we so return. So we know that the field is value, right? If self dot value is less than other dot cell dot node dot value, which is node here, right? So node dot value. So we will return the smallest element here. Okay, so similarly what we will do is we will keep both the, so we are adding a dummy node which is list node of, it can be 0 or whatever value you need, because this is just a temporary one. We will return the next element only. So q is equal to priority queue. Okay, so we need to import this. Yeah, so q, from q import priority queue. So we'll define it. So what we'll do is initially we'll iterate through the list and add the head to it if it is not empty, because it can be empty as per the constraint, right? So for L in list we iterate if L, that means if it is not empty, q dot put of wrapper of L. So wrapper is the method that we have written to enable us to do the comparison proper. So we added the first head nodes of all the list to the priority queue if it is not empty. So we have the reference to the first element of each of the, so in this case the it will have 3 elements. The first element 1, 1 and 2 here. We are putting the reference only, right? So what we will do is then we'll iterate through the priority queue while not q dot empty. So until q is not empty, we'll keep adding it, right? So we'll pop from here, like pop from here in Python. In priority queue, how we'll do is we'll do q dot get off, but we have defined an method here called node, right? So we got the smallest value reference here. Then we have this point, right? So we'll do point dot next is equal to list node of, oh, we don't need to define it, so we'll keep the reference itself. Okay, then we'll move it forward, and we'll also move node dot next, and if it is not none, that means the this linked list in the list is not empty, then we will do q dot put of wrapper of that reference. At the end we had this head pointer, so we'll dot on head dot next. Let's see if this works. Yeah, it works. Let's try submitting this, and yep, okay, so let's go back and see if we can do it in another way. Okay, so I'll reset the canvas. So this was the approach 2, right? So let's see how else we can do it. So there is another way of doing it. So let's see, we have this is L1, L2, L3, L4. Say we have, yeah, so this is the list, right? How we can do is we could if you remember the divide and conquer, we could do something like that. We could use the previous solution for merging 2 linked lists and merge L1 and L2, L2 and L3. Say we had 6 as well, okay, 5 and 6. Then what we do is we'll store the result in the first element, like the merged result would be in L1, merged result would be in L3, merged result would be in L5. Then we'll do L1 and L3 merge, right? So the answer, the result would be in L3. Then we'll do L1, then L3. So the result would be in L1. So ideally the first element will have the result eventually. Okay, so this is another method. So we will be using the previous solution here, if you remember it, and let's see how we can implement it. Okay, so let's write the method to merge 2 linked lists. If you the 2 sorted linked lists. So let's see how we will write it, right? So we are creating the dummy node here. Then we'll do while L1 and L2, if L1 dot value less than or equal to L2 dot value, point dot next is equal to L1 and L1 equal to L1 dot next. Else we will do point dot next is equal to what? L2 and L2 is equal to L2 dot next, right? And we will move point as well, point equal to point dot next. So after the while loop, if L1 point dot next is equal to L1, if there is L2 left out, there is L2, then we'll do point dot next is equal to L2, sorry, yeah, L2. Then we will do head dot next. Okay, so this is how we will merge two linked lists, right? Let's write the main method. Okay, so let's find the length of the list, like how many lists are there in the array, and we have to find this, right? So we'll do the 0th element with the second, 0th with the first, and second with third, then so on. Then we'll do with the next one. So we kind of skip the elements in between, right? So let's call this as interval. Interval is 1. So initially we merge the consecutive elements, then we'll do the alternate elements, then we'll do every third element, merge every third element, and so on. So let that be interval. And while interval less than n, what we will do is, for I in range of, we'll start with 0. The last value is going to be n minus interval, the up to n minus interval, and what we will do is we will keep multiplying it. So we do the next to next element, then we do the second element, then we'll do the every fourth element, then we'll do every eighth element, and so on. So the first iteration, this is interval 1, this is interval 2, and so on, right? So that's what we are going to do here. And the first, so we are going to merge this to the next, the first one in the list, right? So merge cell dot so we'll do merge to list of, we will do the first list of ith list, right? Ith list and list of I plus interval. So initially it will be the first two, then the third two, etc. And we will update the interval to 2. And that then what we will return, the first element is going to have the merge list, right? If n greater than 0, else no. Okay, so what went wrong? Oh yeah, we don't need self because this is this is inside. Hold on, what went wrong? We are list of I. Oh, okay, yeah, we have to multiply it by 2. Here you go. So this is another way of doing the merge of k linked list, right? Let's see if it passes by submitting it. Yeah, so that is success. So this is a hard problem, and I hope you understood the different approaches to solving this. And let's talk about the time complexity, right? So merging of this two linked list takes order of n time, where n is the total number of nodes in two lists, right? And we do divide and conquer, kind of, we divide or do it iteratively. So the time complexity is going to be order of n log k, where k is a number of linked list. And space complexity, we are not using any additional space, we are assigning it to the, we are not using any additional space, so it's going to be order of 1, right? So yeah, So that is the end of this problem, and I hope you were able to understand different approaches to this problem. Please let me know if you have any questions. Please let me know if you have any feedbacks, comments, etc. Please don't forget to subscribe to my channel, and I'll be back with another problem pretty soon. And see you later. Thank you. Bye bye.